let's take a look at the second problem that we have. This one is asking us to compute the complex impedance of the network shown. And once again, we are not repeating this twice more. Okay. So they want us to find Z equivalent. So Z equivalent over here. And we see that we have all three of these are in parallel with each other. So we have a couple ways of going about doing this. First, if we're finding the equivalent impedance, we need to go ahead and calculate the impedance for all of them. So let's write this out real quick. So the impedance of the R is just going to be resistance, which is equal to 100. Same thing as saying 100 angle 0. Z of C is going to be negative J over omega C, which is negative J over omega, which we said is 500 radians per second. Okay. And then also C is 10 microfarads. Oh, cool. Looks like these are the same values as last time, so neat. We'll save ourselves a little bit of work there. So we get negative J 200, which is the same thing as saying 200 at angle negative 90 degrees. Okay. Z of L is going to be J omega L, J 500 radians a second. L is going to be 100 millihenries, J 50, which is equal to 50 at positive 90 degrees. All right, so those are the first three. That's the first three steps. And since we're using the resistor rules, we've got a couple options of what we can do here. You can go several ways about this, actually. So I'm going to break this video up into two separate parts. This first part is going to be the longer way to do it. The second part is going to be the shorter way to do it. So let's just go ahead and do that real quick. So watch this to understand why we do this that shorter way. So just here we go. So the longer method is to say that Z equivalent would be Z parallel 1 over ZR plus 1 over ZC plus 1 over ZL. Okay, which is the same thing as saying 1 over 100 plus 1 over negative J 200 plus 1 over J 50. All we did was just plug in the impedances that we had. Okay, so remember our concept that we had from earlier. Negative J is equal to 1 over J. All right. Then we also had J squared is equal to negative 1. So just keep those in mind while we're working this out. Okay, so if I go take the inverse of all these, I'll have (0.01) plus J 0.005 minus J 0.02. Okay, because what we did is we took this 1 over negative J 200. 1 over 200 is 0.005, but the 1 over negative J is just equal to J, because from up here we can just switch those around. So 1 over negative j is just equal to j. Multiply and divide. And that's the concept we're going to use all through this. Okay. So 1 over that. We'll combine our like terms. So 0.01. We'll get negative j 0.015. Okay. And then now, from here, we can branch off and do a couple things. The easier way, and this is kind of like we had to make a decision. I'll do one way in red and the other way in blue. So let me do the red way first. Red, bad. So just keep that in mind while I'm writing all this out. So if we're doing the complex conjugate route, 0.01 plus j 0.015, 0.01 plus j 0.015. Complex conjugate is just that, but we're changing the sign right there. We'll multiply the top and the bottom by that. Okay, so when we do that, I'm actually going to have to go down here for this. I will get 0.01 squared plus 0.01 times j 0.015 plus negative j 0.015 times 0.01 plus negative j 0.015 j 0.015. Okay, so that's just the bottom. Then the top is going to be 0.01 plus j 0.015. All right. So then now what we can do is we'll combine these down. So I'll notice right here that right here and right there, those two terms are the same, so those will just cancel out with each other. So those will go away. Then I'll have my 0.01 squared term right there. Then I'll have my plus. So j times. So I'll have negative, pulling this negative out, negative j squared, 0.015 squared. Okay, just multiplying the magnitudes now. You remember from what we had up here, j squared is equal to negative 1. So 0.01 plus j 0.015. Filling that in. Save a little bit of space. Okay. So when we do that, now we'll have 0.01 plus j 0.015. Like we said, j squared is going to be equal to negative 1. So this turns into 0.01 squared plus 0.015 squared. And when we do that math, 0.01 plus j 0.015. 5. 3.25 times 10 to the negative fourth. Okay, so all we're going to do now is take this denominator and we'll divide it into both the real and the imaginary terms, and we will get 30.726 for the real part, then plus j 46.15 for the imaginary part. All right. So They want it in both polar and rectangular forms. Okay, so polar and rectangular. Right here, this would be, remember we're going to do the tangent inverse of y over x. So I'll just write that up here, I guess. Theta is equal to tangent inverse y over x. And what would that give us? And then I'll write z as square root x squared plus y squared. Okay, and when we do that, we will get, we're still in the red zone, remember that, so 55.47 at 56.31 degrees. Okay, and this is equal to z equivalent. Lot of work, right? Not fun multiplying, remembering all those values. Pretty gross. Let's go with blue now. So now we'll start from here at this point that we had. And I'm going to rewrite it down here. So 1 over 0.01 minus j 0.015. Now what I'll do is I'll just convert this into polar using the same equations up here, just using it way earlier. And when I do that, I'll get 0.01802, an angle of 56.31 degrees. And remember, we're going to divide, so be 1 over 0.01802. We're going to subtract 0, because up here this is technically an angle of 0. So 0 minus negative 56.31 degrees. So therefore our value is going to be 55.47 at an angle of 56.31 degrees. And then if we do the component form, so where x will be equal to 55.47 cosine of 56.31, and then y is equal to j 55.47 sine of 56.31 degrees. Then we would get, it's the ugliest 3 I've ever drawn, 30.73 plus j 46.15. Okay, so there are options when it comes to these. Okay, so this is one method. I'll show you a second method. So typically, knowing that part of z equivalent and then getting to here is pretty important. And then you can just, I would go with the blue route because I don't like a ton of algebra and multiplying and foiling out. It takes way too long. But I'll see you in the next video where I'm going to redo this problem, but I'll do it in a different way. So that way you can decide which method you like better, and you can go from there. All right, I'll see you in the next video.